Now we will start our journey towards mastering calculus, and the journey starts from differentiation, and the differentiation starts from chain rule. Once we understand chain rule, our differentiation is going to be very easy. Once differentiation is good, we can do well in integration, differential equation, definite integration, everywhere. So just concentrate how we just follow the basic things in doing the differentiation of our composite function. If we have to differentiate x to the power n with respect to x, it is n into x to the power n minus 1. The key is hidden here. If you understand the formula well, your thing is done. See, what's the key? Whatever is here, same thing is here, then only we are getting the output. So, how to read this? This is differentiation of something to the power n. Something means some variable. It can be anything. With respect to that thing only. And the result will be n into that thing to the power n minus 1. One example I am taking. See, if we have to differentiate just like this with respect to x. Now you tell me, will this give result with respect to x? No. Whatever thing is here, it will give result with respect to that thing only. That is the basic of the chain rule. We have to manipulate, we have to make the arrangement so that differentiation is possible. So at first instance, what is this? It is something to the power n. So we will give the treatment of that formula only. How? Just see. If I just write d x plus 2 to the power 3 with respect to something is x plus 2. So this is x plus 2. Now you see the thing is masked. Something to the power n with respect to that thing only. We have introduced that thing our own. To balance it out mathematically, we need to write this in the numerator as well and dx. So if I am saying I am mathematically balanced, I am right. I have introduced this thing my own. I have written this thing here to balance it out. Now it will give the result something the power n with respect to that is n into that is 3 into that thing x plus 2 to the power n minus 1. 3 minus 1, that is 2 you can write, and here differentiation of x is 1 and differentiation of 2 is 0. We know that differentiation of a constant thing is 0. Very much clear? Now see this formula, differentiation of sin x with respect to x is cos x. What is the key here? Again the same thing. Whatever angle is here, the same thing should be there. Then the result will be cos that thing. So first instance we have to identify which form it is going to be. Suppose I am taking one example. If y is equal to sine square x. What is this? Can you tell me? I asked the student, what is this? Which formula is this? Is it trigonometrical or algebraic? The student says, sir, it is trigonometry. Why? Because sine is there. No, at first instance it is algebraic. See how? So you have to identify at first instance what it is. Then you proceed. You will get the things automatically. So if you just write this thing as, you know the meaning of this, sine square x is sine x whole square. Sine x square is different. Angle is x square. Sine square x means sine x to the power 2. So now you see, what is this? This is something to the power n. We will give the treatment accordingly. If I just differentiate dy by dx is equal to sine x with respect to x, I need to write because I have written dx here. To balance it out, I will write here. Now I have to make the chain accordingly so that output is possible, so that differentiation is possible. So we can just write differentiation of sine x whole square with respect to, can you tell me, something to the power n. So something is here, sine x. You just write sine x here. I have done my own. To balance it out, I need to write in the numerator as well. Now you see the conditions are met. So output will be there. So differentiation will be there. Something to the power n, and its result is 2 into that thing. We are not concerned about that thing because we are just naming it something. So we give the treatment to the power. So 2 into something to the power 2 minus 1, that is 1. And here the conditions are directly made. Differentiation of sine x with respect to x, that we know, this is cos x. Very easily we can differentiate if we just identify at what formula is needed to be applied at first instance. One more example I am taking. This is y is equal to e to the power sine x, and we need to differentiate that. So first instance, what we need to write, d by dx of y and d by dx of this thing here, both sides. Now we have to think at first instance what it is, e to the power something. So which formula will be applicable at first instance? This one. Is it? Differentiation of e to the power x with respect to x is e to the power x. So we'll give that treatment, d e to the power sine x. So with respect to e to the power something, with respect to that thing only, and that thing is sine x. So to balance it out, we need to write d sine x here, dx. You are understanding whatever I am writing in the denominator, to make it applicable for the derivative, I have to balance it out in the numerator as well, so that mathematically we are correct. So it is e to the power something with respect to that thing only. The matching is here, and the result is e to the power that thing, and that thing is, sine x. And this is very simple. You can just write cos x. One more typical example I am taking here. See, y is equal to ln sine root under x, like this. Is it? First thing we have to do, d by dx of y, d by dx of that thing we need to write. So it is d by dx of y, d by dx of, this is ln. What is the difference between ln and log? I have seen students say ln is something, but they don't know. Ln is actually log with the base e, exponential. But if we write log, then the base is understood to be 10, natural log. So it is actually log with the base e. So now onwards, the confusion between ln and log is no more. You clear? Now, at first instance, it is ln something. Is it? So we have to give the treatment of this at first instance. We won't be seeing this thing. This is what? Something. Rubbish. We don't have to concentrate on that at the first instance. So we will write d ln sine root x with respect to, this is sine root x. We are not concerned about that. We are concerned about ln something. This is just playing the role of something. So we need to write here d sine root x. And what is this? Can you tell me? This is sine something. Now what is something now? Something is this. What was something here? This complete. Now something is root x into, differentiation is not complete until at the last denominator dx is coming. So we have to give the treatment to this, d root x, that is x to the power half dx. So now just give the treatment. What is that? Ln something, 1 by that thing, 1 by that thing. Sine something with respect to that thing is cos that thing. cos root x, and x to the power half, the treatment of x to the power n. So this is 1 by 2 x to the power n minus 1, that is half minus 1, so minus half. So this is the actual differentiation. Now you are understanding how to make the chain and get the answer. Now we will just try to do it directly without showing the chain. Suppose the thing is like y is equal to e to the power sine ln x. So without forming the chain, if we are now competent, we can just answer it. You just write dy by dx here. First instance, it is e to the power something and something we are not concerned about. In next step, we will think of something. So e to the power something will give e to the power that thing only into. Now we have to concentrate on something. What was something? Sine ln x. Now what is that? Sine something. What is the treatment of that? Cos that thing. So it will be cos that thing. Now what is that thing? What is something here? Ln x. So the differentiation of ln x is 1 by x. Very simple. Once you master the thing, firstly you just try to solve the problems by writing with respect to. Once you master it, you just write directly. One more example I am taking. If it is y is equal to tan root under ln x. Yes. So you just tell me what will be the answer if I just differentiate. Very simple. First instance, you need to give the treatment to tan, and the differentiation of tan is sec square x. So it will be sec square x. X is this thing, sec square something. Don't think that this square is there and that root will be removed. That is square of the trigonometrical thing, not of the angle thing. So sec square that thing. Now we have to give the treatment of that thing. What is that thing? That thing is under root ln x. So what is that format? Under root something. That means something to the power half. So its differentiation will be half into that something to the power minus half. Next we have to give the treatment to the something here in the previous step, that is ln x, and the differentiation is 1 by x. Now chain rule is very much clear to you. Apart from that, I think that you remember the formula u into v and u by v. Just for the sake of revision, I am writing here, d by dx of u into v. U into v means product form. So it is u, first function as it is, differentiation of v plus v as it is, differentiation of u. And that of u by v also I am writing for your revision, u by v. What's the meaning of u by v? Something by something. Sin x by ln x. E to the power x by sin x. Something by something like that. So it is, v differentiation of u minus u differentiation of v divided by v square. You remember one basic thing you might be knowing, that if we need to differentiate 3 sin x like that, okay, so what we do, no need of applying u into v. This constant can be taken outside and we can just differentiate this thing 3 cos x. Like this, these small things, you need not go for applying u into v or u by v formula. Sometimes some constant is there with a variable function, take it outside and differentiate the thing. But a constant is trapped alone, its derivative is 0. Suppose we need to differentiate just 3, so its derivative will be 0. And moreover, just something is in the plus or minus form, sin x plus e to the power x, you just differentiate first sin x plus then e to the power x or minus whatever is there. Basically no rule is there regarding that. So into and quotient form you have to remember. Derivative of implicit function. Firstly, we need to know the meaning of word implicit function. What is implicit function? So we will see what is explicit function. explicit function is the function in which y can be made subject easily. Suppose it is y is equal to 3x square minus 1. Y is subject. Y is equal to sine 2x plus 5. Y is a subject. But see, sometime you encounter equations like x square plus y square is equal to 2xy. Now it is very difficult to make y as subject. So which type of function is this? This is implicit function. So now it is very much clear what is explicit function and what is implicit function. Now we are concentrating on differentiation of implicit function. Suppose I am taking this and we need to differentiate this. What general process we follow? You just write differentiating both sides with respect to x. Just this is the common language. You write this thing and your work is done. What is the translation of this language? The translation of this language for this question is d by dx of x square plus d by dx of y square is equal to d by dx of 2xy. Now you can easily differentiate. What is that? 2x. You can easily write. Be careful what is the differentiation of y square with respect to x. So if follow the chain rule, it will come out to be 2y dy by dx. Be very careful. While differentiating any term having y, don't forget to write dy by dx. So here, if I am taking 2 common, it is u into v. What is the differentiation? U as it is, that means x as it is. Differentiation of y, that is dy by dx, plus y as it is, differentiation of x with respect to x is 1. Now you need to make dy by dx as subject and you will get the value of dy by dx. Suppose I am doing here dy by dx, I am taking common here. So it is 2y and I am bringing this thing this side. So it is minus 2x and here I am left with 2y minus 2x. So dy by dx we can easily get dy by dx is equal to 2y minus 2x divided by 2y minus 2x. So this is the basic method of differentiation of implicit functions. One more example I am taking. Y is equal to sine x plus y. So what is this function? Implicit or explicit? It is implicit. Why? Because y cannot be made subject independently, because y is here as well. We cannot get rid of this y and take to this side. So we will follow that process. What we will write? The first sentence we need to write differentiating both sides with respect to x. Second step, what we need to do? D by dx of this thing, d by dx of this thing. Now you follow the process. This is dy by dx and here you follow the chain rule, sine something, that will be cos x plus y. And now differentiation of x plus y, x1 y dy by dx. Now you make dy by dx as subject and you will get the derivative of y, differentiation of y. If you are just lagging in the basic differentiation, follow the playlist given above in the I mark. Follow that playlist, you will learn differentiation very easily. Now we will see differentiation of parametric form. You know the meaning of parametric form? Parametric form is that form in which x is defined in terms of something else and y is also defined in terms of that thing only. One example I am taking, if y is equal to sine t, x is equal to cos t, and we need to find dy by dx. Parameter means it is represented in terms of something else, some parameters. This thing also something else, some parameter. So how to find dy by dx in such type of problem? What you need to do, you firstly find dy by dt, because the function is in the terms of t. So with respect to t, you differentiate. It is going to be cos t, and here dx by dt, it is giving you minus sin t. Is it? Because the differentiation of cos t is minus sin t. Now dy by dx will be, dy by dt divided by dx by dt. So what is that? Cos t divided by minus sin t, and that is minus cot t. So easily you can find the differentiation of parametric form. One more example I am taking. If y is equal to e to the power sin t and x is equal to e to the power tan t, we need to find dy by dx. Simply you just proceed. Dy by dt. What's the differentiation? Directly we can write. We have done that thing in the chain rule earlier. So this will be e to the power sin t into cos t. Firstly we gave the treatment to the e to the power something, then that of something's treatment, that is cos t. And here dx by dt is e to the power tan t, and derivative of tan t is sec square t. So how to get dy by dx? Dy by dx is actually this divided by this. So it is e to the power sin t into cos t divided by e to the power tan t into sec square t. Very easily we can find the derivative of one thing with respect to t, another thing with respect to t. Then by actual manipulation, here we are just dividing and getting dy by dx. Now very important thing I am telling you, double derivative, double differentiation. What is the actual meaning of double derivative? That should be very much clear. Otherwise we will make mistakes certainly. The actual meaning of d square y by dx square is d by dx of dy by dx. This is actual meaning. Don't think that it is dy by dx whole square. No, this is wrong. This is the actual meaning. So never confuse. I'm just taking one example. Suppose y is equal to sin x. We need to find double derivative. So dy by dx is what? Cos x. And we need to find d square y by dx square. What is that? This is d by dx of dy by dx, that is cos x. Just need this thing. And this is minus sin x. We can easily find the double derivative. Just proceed in that way. See this problem, we got the value of dy by dx. Okay, here if we need to find d square y by dx square, how to proceed? See, d square y by dx square is equal to d by dx of dy by dx. Firstly you write this thing. What I have seen that if we need to find d square y by dx square here, directly what the students do, they just differentiate here 2 times. That means they get d square x by dt square, and here they get differentiate this again 2 times, d square y by dt square, and here d square y by dt square, and just divide. When you divide these 2 things, the answer will be d square y by d square x. That is not the double derivative. That is meaningless. So never do that thing. Basic definition all the time you follow. See, you will be trapped here if not concentrating. How? We need to write here dy by dx. We got in that particular problem minus cot x, minus cot t. Sorry. Minus cot t. If I just say what is the answer, I have seen students say cot t is minus cosec square t. Is it the correct answer? No, you are trapped. How? See, this is cot t and we are differentiating with respect to x. It won't give you result. Because the basic of chain say cot t is here, that is to be differentiated with respect to t only, then only it will give result. So you need to make the arrangement. Again, remember the chain rule, very important. So minus, I am taking common, d cot t with respect to dt, I have written my own. So to balance it out, dt here and dx. So what's coming out to be minus differentiation of cot t with respect to t, it will give you result minus cosec square t, and dt by dx, we got value of dx by dt. So dt by dx is what? Minus 1 by sin t. Dx by dt is this thing, so dt by dx will be reciprocal of that. So it is coming out to be actually minus cosec qt. So be very careful while finding the double derivative in the case of parametric form. Now it comes the turn of derivative of inverse functions. Basic derivatives of inverse function, you remember, differentiation of sine inverse x, that is 1 by under root 1 minus x square. Differentiation of cos inverse x, that also you remember. What's that? This is negative of this, very easy to remember. Just I'm writing sine, cos and tan. Differentiation of tan inverse x, it is 1 by 1 plus x square, and that of cot is minus of that. Same way, differentiation of cosec, differentiation of sec, you can just remember. We are developing a technique how to make a substitution to make complex derivatives of inverse functions in simplest form. One example I am taking, if y is equal to tan inverse 2x by 1 minus x square. If we just go for direct differentiation of this thing, it is little bit tedious, because firstly tan inverse 1 by 1 plus the complete thing whole square into the derivative of this thing, if we follow the chain rule, it is tedious. Now I am just making small substitution here. If I put x is equal to tan theta, what is happening? See, y is equal to tan inverse 2 tan theta by 1 minus tan square theta. Do you know what is that? Tan inverse tan 2 theta. So you are just left with 2 theta. We use tan theta, made it simple, and now you put the value of theta here after making it simple. 2 into theta is what? Tan inverse x. So very easy to differentiate now. What is that? dy by dx is equal to 2. Differentiation of tan inverse x is 1 by 1 plus x square. So we will develop the technique, what substitution to be made to make the problem simple, to get rid of the differentiation at first instance. Certain rules, certain substitution I am giving you that will make your problems very easy. Wherever you see 1 minus x square, what you need to put here? Put x equal to sine theta. If under root 1 minus x square, if you put x is equal to sine theta, that will be 1 minus sine square theta, that is cos square theta, and just cos theta. It will be very easy. Wherever you see 1 plus x square, what you need to put? Put x is equal to tan theta. If you need to put something for 1 plus x or 1 minus x, put x is equal to cos theta, or some people put cos 2 theta. If you put cos 2 theta, 1 plus cos 2 theta will be 2 cos square theta, and 1 minus cos 2 theta will be 2 sin square theta. So these are very basic simple substitutions. If you remember, your things will become easier. All the time you won't find 1 minus x square. Suppose it is a square minus x square. What you need to put? X is equal to a sin theta. You can also put a cos theta. Here you can also put cos theta. because anyway you are just getting rid of root or making two terms single one. How? You see, a sine theta, if you are putting, this is a square sine square theta. On taking a square common, 1 minus sine square theta, that is a square into cos square theta. So simple term is there. See, if it is a square plus x square, what you need to put? You need to put x is equal to a tan theta, and for a plus x or a minus x, you know, x you need to put as a cos theta or a cos 2 theta. So what's my recommendation? You just put that, make it simpler, and then put the value of theta and then integrate, then differentiate. One example I am taking, suppose y is equal to tan inverse 3 plus x by 3 minus x, both inside root. What you need to substitute here for x is equal to, can you tell? X you can put a cos theta, that means a is 3 cos theta. So put x is equal to 3 cos theta. So see what it is coming out to be. Y is equal to tan inverse, and here 3 plus 3 cos theta by 3 minus 3 cos theta. You take 3 common. So what it is there? 1 plus cos theta. What is that? 2 cos square theta by 2. And this is 1 minus cos theta, 2 sine square theta by 2. So 2 getting cancelled, it is cot square theta by 2, and ultimately we are getting y is equal to tan inverse cot theta by 2. Tan inverse and cot cannot cancel out. So we need to convert this cot in the form of tan. What we will do? We will write y is equal to tan inverse tan 90 minus theta by 2, pi by 2 minus theta by 2. Now what is that? This is just pi by 2 minus theta by 2. So what is that? On actual substitution, actual value putting, it is coming out to be pi by 2 minus 1 by 2 into theta. What's theta here? Theta is cos inverse. You just write cos theta is x by 3. So theta is cos inverse x by 3. Cos inverse x by 3. Now differentiation is very easy. You can find dy by dx. What is that? Pi by 2, you know, 0 minus 1 by 2. And that of cos inverse, you just remember the formula, minus 1 by under root 1 minus x square. That means x by 3 square into differentiation of x by 3 is 1 by 3. You just follow. So what we are seeing that by proper substitution, things are becoming easier. If you are lacking somewhere in the basic derivatives, basic differentiation, follow the link I am giving above. Just see that is mentioned in the I sign above. You see the playlist is there. You will find all the topics of differentiation there. Now we will see double differentiation, triple differentiation, or we can say the higher order derivative of a function. Suppose y is equal to sin x. Okay. So what is dy by dx? That you know, it is cos x. If I say what is d square y by dx square, this will be minus sin x. So we have to concentrate what is the actual meaning of d square y by dx square. D square y by dx square is not dy by dx whole square. So never confuse with this thing. Be careful. What it is actually that I am writing here, this is the double derivative of y. That means differentiation of dy by dx. This is very important definition. Be careful. Some people stuck when they follow this definition. So be careful in following this definition. I'm just taking one example. Y is equal to sine t, x is equal to cos t. Okay, we need to find d square y by dx square. So see what process we will follow. You know, dy by dt, which form is this? You remember? It is parametric form. Dy by dt is cos t, dx by dt is minus sine t. So what will you do next? I have seen that some people do, they just differentiate d square by dt square, and cos t is minus sine t, and d square x by dt square, that is equal to minus cos t. And they say that d square y by dx square is equal to minus sine t by minus cos t. That is totally wrong. Be careful. That is not correct. What we have to do, that I am doing here. You firstly find dy by dx. How you will find? By just dividing cos t divided by minus sine t, that is minus cot t. Is it? Now follow the basic definition. Here is the important point line. D square y by dx square is actually d by dx of dy by dx. This is important definition. See here, d by dx of dy by dx, you got minus cot t. So what is that? You can take minus common, and differentiation of cot t is minus cosec square t. Is it? Into, the important thing is that chain rule, you have differentiated this with respect to t, not with respect to x. So by chain rule, you need to write dt by dx here as well. This is important thing. Now you just put, this is cosec square t into dt by dx. Dx by dt is minus sine t. So dt by dx is 1 by minus sine t. So what it is coming out to be? Minus cosec cube t. And that is the double derivative of the given problem. So carefully follow the definition and your problems will be solved out. One example I am taking, y is equal to sine inverse x whole square, and we need to prove 1 minus x square y2 minus x into y1 is equal to 2. You know what's the meaning of y2? y2 means double derivative, y1 means single derivative. That means y1 is dy by dx and y2 is d square y by dx square. How to proceed? See, firstly we will get dy by dx here. What it is? Something to the power n. So 2 sine inverse x into differentiation of sine inverse x is 1 by under root 1 minus x square. For such type of problem where you need to prove the things involving y1 and y2, try to take the denominator thing of the RHS to the LHS side. So on taking this, it is coming out to be 1 minus x square under root dy by dx is equal to 2 sine inverse x. Now you again differentiate, differentiating both sides with respect to x. What it will be? It is u into v format. So u as it is, differentiation of v, that means d by dx of dy by dx is d square y by dx square plus dy by dx as it is, differentiation of under root 1 minus x square is 1 by 2 under root 1 minus x square into differentiation of 1 is 0 and that of x square is 2x. So minus 2x is equal to 2 into differentiation of sine inverse x is 1 by under root 1 minus x square. Now on taking LCM, this 2 is getting cancelled out. So under root 1 minus x square is LCM here in the LHS side. it is coming out to be 1 minus x square under root into 1 minus x square under root is 1 minus x square d square y by dx square plus minus, it is coming out to be minus here. So minus x dy by dx is equal to 2 divided by under root 1 minus x square. So cancelling out under root 1 minus x square both sides, we are just left with 1 minus x square. What is this? This is y2 minus x into, what is that? y1 is equal to 2, and we prove the thing. Hope you are understanding double derivative, what precautions you have to take while finding d square y by dx square. Now we will see how differentiation of certain things can be made very easy using logarithm. You encounter a problem, y is equal to x to the power sin x. Which form this is? This is variable to the power variable. So in such type of differentiation, we have to make use of logarithm. Why differentiation of this thing is not possible? Don't tell that differentiation of this thing will be sin x into x to the power sin x minus 1. Why? You have given the treatment of x to the power n. See, x to the power n form is applicable when n is a constant. But is the power constant here? No. So we have to make different approach here. We have to get rid of the power on the variable. What we can do? On taking log both sides, this is ln base e. Log means whatever meaning is here, ln x is like this, and we just write this as ln x. Okay, so don't get confused if I am using the word log. So on taking log both sides, it is coming out to be log x to the power sin x. Just remember the formula, log m to the power n is what? N log m. So what it's coming out to be, sin x is coming here and it is just ln x. Now easily we can differentiate. Differentiating both sides with respect to x. What is the differentiation of log y? Is 1 by y into dy by dx is equal to, this is u into v form, sin x as it is. Differentiation of ln x is 1 by x plus ln x as it is. Differentiation of sin x is cos x. So dy by dx is coming out to be, y we are taking to that side, which is actually x to the power sin x. This is for y I am writing, and it is sin x by x plus ln x into cos x. This is the simple derivative principle for variable to the power variable. Now see, if y is equal to sin x to the power x plus x to the power sin x, like this. Okay, what you will do? You just remember, if it is variable to the power variable, you have to take log both sides. But log m plus n is nothing. So we don't have the formula. So directly we cannot take log both sides. So what treatment we will give? We will individually treat the things. This thing we will take as u, this thing as v. Now we will give the treatment to u and that to v and then put. So what actually dy by dx is du by dx plus dv by dx. Now giving treatment to u, u is actually sin x to the power x, variable to the power variable, taking log both sides, ln u is equal to x ln sin x. So we can find du by dx from here. On differentiating both sides, this is du by dx 1 by u du by dx ln u 1 by u du by dx is equal to u into v, x as it is, ln sin x 1 by sin x into sin x is cos x plus ln sin x as it is, and differentiation of x is 1. So from here we can find du by dx easily. Now giving treatment to v, we will take x to the power sin x. Same process we will follow we did earlier, taking ln both side. Ln v is equal to, on taking ln, it is sin x into ln x, and just give the treatment and find dv by dx. Whatever value you are getting, you put it here, you will get dy by dx very easily. Sometime we encounter problem x to the power y plus y to the power x is equal to 5. We need to find dy by dx is equal to what? Just give the treatment. We cannot take log both side. Why? Because it is something to the power something, variable to the power variable, variable to the power variable, and on taking log it will be log m plus n, which we cannot proceed. So we will give individual treatment uv. So actually du by dx plus dv by dx is equal to d5 by dx, which is 0. So we need to find du by dx here, dv by dx it here, and we'll put it here, and from that we will try to get dy by dx. See how I am proceeding. I have taken u is equal to x to the power y. So ln u is equal to y ln x. On differentiating, 1 by u du by dx is equal to y as it is, differentiation of ln x is 1 by x, plus ln x as it is, differentiation of y is dy by dx. Careful. So du by dx is coming out to be u into that thing. U means x to the power y into that thing means y by x plus ln x dy by dx. Okay. Now we are finding dv by dx. Why? We have taken y to the power x is equal to v. So ln v is equal to x ln y, 1 by v dv by dx. On differentiating is giving us u into v x. This is 1 by y dy by dx plus ln y x as it is, and differentiation of x is 1. So dv by dx is equal to v into that thing. V is y to the power x into that thing means x by y dy by dx plus ln y. So on putting the value of du by dx and dv by dx here in the equation, we will get an equation in the terms of dy by dx, and we can make dy by dx as subject and get the value of that. So on putting the value here, it is x to the power y into y by x plus x to the power y into ln x dy by dx for du by dx plus dv by dx is y to the power x by y dy by dx plus y to the power x ln y is equal to 0. So on making dy by dx as subject, we can get the value of dy by dx. Dy by dx taking common here and here, it is x to the power y ln x plus y to the power x into x by y, and taking the other string not involving dy by dx to other side, it is giving minus of x to the power y y by x plus y to the power x ln x. Now from that equation we can get the value of dy by dx is equal to, this is minus x to the power y y by x plus y to the power x ln x divided by this thing x to the power y ln x plus y to the power x into x by y. So this is the basic principle. On taking log both sides, we can make the things easier wherever we are encountering the problem. Variable to the power variable. This is very important. So always try to take log. Using the properties of log, we can make the things very easy. Hope you are understanding derivatives using logarithm. Don't forget to subscribe my channel. This is your loving Santosh Kumar. Thank you. Bye bye.